Okay. Full screen. So the easiest thing would be, are we ready to start? The easiest thing would be for me just to start number 4 again from the beginning, but really I was in the middle of part 2. Yeah. Part 1 was only 2 marks. So just to rewrite the information again, the first factor or equals, don't make a mess in my classroom, Joseph. Yes. The first factor or equals 4, right please, 4 plus lambda, and then minus 7 minus lambda, and then there's no there, so that's minus lambda there. And then the second one, L2, is 5 plus mu a, minus 3 minus 3 mu, and then the last one is 6 plus b mu. Is that right? Yeah. Now the first one is, actually I won't bother writing it again because I started it the last time, is use the dot to show that they're perpendicular. And then what equation did we get the last time? Focus here, people, focus here. What equation did we get the last time if they're perpendicular? The dot needs to equal 0, and we made this equation. Yeah. Now, let's try to find the solution for where they meet. So I have this equation. I also have this equation. I also have this equation. And I also have this equation. We have, yes. Which one, sorry?
Is that B mu?
Sorry, that's a, yeah, my handwriting. Thank you. That should be a B. Actually, maybe to make it a bit clearer, I'll call it like capital B, so I don't confuse it later. You don't have to do that. It's just so you can help to read it. So this here is capital B. Okay. Now, unfortunately, solving systems with 4 variables, strangely, is not on the course, but is in this particular question. The business students learn how to solve 3 or more variables, but it's not part of the algebra for the science and engineering students. So anyways, for you, I know it's 4 variables, but it's not as big as it looks. So the first thing you do is, let's write down the variables in each one. Because I'll try and make this as clear as possible. So the first one has an A and a B in it. The second one has an A, a mu, and a lambda. The third one has a mu and a lambda. And the last one has a mu, a lambda, and a B. Now, I will give you my advice on how to solve this. And it's a trick, or it's a tip, which I find is very helpful. What you should do is look at which one appears the least. So here you have A only twice. And you see, of course, you have B only twice. The one that appears the least is the one you should try to get rid of first. So let's go with the A first. These two have A in it. See here? So what I'll do is I'll try to get rid of the A. So if I take this over to the right, now I'm going to remove this and then bring this over to the left. So that's minus 3 here, and then that's A here. And then I'll substitute that into equation number 2. And you'll notice now, equation number 2 becomes this. Yeah. 4 plus lambda equals 5 plus b mu minus 3 mu. And I should try to clean that up if I want. Well, the only thing I can really do is put the 4 and the 5 together. So if I take the 5 over to the left, 4 minus 5 is minus 1. And then if I take the lambda over to the right, so I'll end up with minus lambda here. So I took the 5 over and the 4 over. So let's recap what I have. Now I have, this is my new equation 1. I put that into that, and then the other 2 here, minus lambda. I'll take the lambda over to the right, and I take the 3 over to the left. So minus 7 plus 3, minus 5, yeah?
Minus 4.
Yes, minus 4. I haven't actually drunk my coffee yet.
Oh,
Minus 4.
No.
Door's right there.
Coffee.
Yes. I take the lambda over to the right. Lambda minus 3 mu. That's my equation 2. And all I'll do with number 3 is I'll take the 6 over. So minus 6 equals lambda plus b mu. That's number 3. Okay, and then what we do is we begin again. We recap. So first equation was I got? It's got a lambda, a b, a mu. Yeah? And then this one here, lambda and mu. And this one here, lambda, mu, and b. So which is now least frequent? You see the b, you only have it twice. So then what we do is, well, which equation would be easier to get the b? I think this one here is not too difficult to get the b. So you could rewrite that as minus 6 minus lambda over mu equals b. And then what do you think I do with this? What do you think I should do with this? Well, actually, if you want to be really smart about it, I can leave the mu here. Why would I want to do that? Well, look at what I'm going to replace it in. What equation will I put this in? 1, 2, or 3?
3.
Well, I can't put in 3 because it came from 3. Put in 1. But what's in 1? B mu. And what have I got here?
Same thing.
B mu. Like, if I divide by the mu, that's okay, because when I put it in here, what will happen with the mu's? They'll cancel. Yeah, so it doesn't really matter what way you want to do it, but you'll end up getting minus 1 equal to minus lambda minus 6 minus lambda minus 3 mu when I substitute that in here. And then rewrite in number 2. Minus 4 equals lambda minus 3 mu. Now what are we left with? How many equations? We've simplified this down into 2 equations with just 2 unknowns. So if I just go, don't worry, I'll scroll back up. Just cleaning this up, how many lambdas? Minus 2 lambda minus 3 mu equal to, what number? 5, if I take the 6 over. And then in the other one, I get lambda minus 3 mu equal to, come on please, are we awake? Minus 4. Now if I want to cancel, I'll subtract. So that becomes minus 3 lambda equal to 9. So lambda equals minus 3. That is my first answer. Now how do I get mu? Sub it in. Let's sub it into, say, this one, for example. So I get lambda minus 3 mu equals minus 4. So minus 3 mu equals 3 minus 4, which is minus 1. So what does mu equal? 1 over 3. I substitute that in here, into this one. Okay. Now I have lambda and mu. The next one to get, I think might be the best one, might be the b. Because b equals minus 6 minus lambda over mu. So I'll just write that again here. B equals minus 6 minus lambda over mu. Isn't that right? Yeah. So now I know the lambda and mu. Minus 6 minus lambda over mu. That would be minus 9, will it? Minus 6 plus 3 is minus 3. Yeah, minus 9, right? So now I have the b equals minus 9. And now get the a, which one? There we go, yeah. A equals b minus 3. So a equals b minus 3. A equals b minus 3. So minus 12? Isn't that what I said? B minus 3, isn't it? Yeah, b minus 3. So minus 12 is the a.
Minus 9?
Yeah, minus 9. Now, it's long, but then at the same time, how many marks do you think for this question?
5.
No, we're not quite 12, but not far off 9. So 9, and then from the previous part was 2. So in fact, it's 11 marks. So the last part is 5 marks.
Okay, sir, you said this wasn't in our curriculum, so what if they get something
No,
else?
no, no, no. I'm saying that
It wasn't.
when you look at really big problems, this is actually small compared to what the business students do. I'm just saying we don't devote a lot of time to practicing this type of algebra, but you've done stuff like this. What technique did I use to solve this system? Substitution
And elimination.
and elimination, which we did in semester 1. The only difference is I have to do it like 4 times instead of 2 times. So, I mean, it's stuff that you've done already. The only difference is it's bigger. And I'm trying to give you advice on how to approach it. And my advice is write down the variable in each line and eliminate the one that is least frequent. That is my best advice to do. Okay?
How about replacing the lambda and the mu with
Yeah,
x
well-
and y? It's gonna be easier.
Well, it doesn't change how many you have to solve.
That's it, but it's not easier.
It looks easier, that's fine if you want to do that, yeah, I have no problem with that. Okay, so the question is find the lambda, the mu, the a and the b, and now we've done that. And then the last one is show that point P lies on L1.
No, this is.
Show that the point P with that position lies on L1. That's the last part.
5 minus 1 minus 8.
Yeah, which is the P, 5 minus 1 minus 8. I need people to write these answers down because I'll need to use them for the next part. So can you at least write the answers down? Thank you. Will I scroll up a bit?
Yeah.
Can you, how far?
More.
More? Tell me when to stop.
Just a second.
Yeah. Will I go on to part 3? Okay, so part 3. Show that P. What's wrong, guys?
Nothing. Calculate.
I hope so. Show that P is on the line L1. Now, can you please read out the equation for the first line I gave you?
A is equals to b minus
No,
3.
no, no, the very beginning. What's the first line? The very beginning, up here.
4
4.
plus lambda
4 plus lambda,
minus 7 minus lambda
minus 7
minus lambda
minus lambda,
and then minus lambda.
and then minus lambda.
Yeah.
Great. Now, are you sure about that?
Yeah. It's meant to be.
5 minus 1 minus 8.
But
No,
the function
that's
answer. How?
4 plus lambda minus 7 minus lambda minus lambda.
No, the function is going to be on.
Yeah, so it means either they made they must have made a mistake here. I wonder if they meant the second line, L2.
So
Let me check. Well, we have the answers.
take it.
What the first question, what they wanted to do in the last part is show that this point is on the line L1. Now I know it's actually not on the line L1 because what would I need to make lambda equal to get the points at the top to match? 1. But what would this one be?
Not 1, obviously.
Not minus 1 and of course not 8.
Maybe it's-
So let's have a look at what
Maybe
they...
it's line 2.
Yeah, I wonder maybe they meant line 2. We'll have a look at the marking scheme. Because this answer I'm just taking from the start of the question. It's nothing I calculated. Version 1, this is it, isn't it? Version 1 mark scheme. question 4. The point P, 5i, what's wrong with this? That's, I wrote the same one down, didn't I? 5 minus 1 minus 8, yeah?
5, yeah.
Corresponds with lambda equals 1 and so lies on L1. No.
Makes sense.
5. Did I, hang on, I wonder if I wrote,
Oh, what if you put lambda, no, minus lambda on the top and then 7 minus lambda on the bottom? Never mind. Yeah, exactly. That's what I said.
I think something's wrong here. He says to put lambda equal to 1. If I put lambda equal to 1, what vector do I get if I put lambda equal to
You
1?
would have this on here and this on the bottom.
No, but you can't swap them. You have to put lambda. I get 5.
And you'd get
Minus 8.
minus 8 and negative 1. If you swap them, you'd get the same order.
Yeah.
I think I see what happened here. If you look at the question, you see, yes, okay, there's a typo in the exam. In the question, I don't have it here, they have I and J,
Yeah.
but they meant I and K. That's why you said it looks like they're just the wrong way around. I'll show you now what happened in the exam. So if you look at the question, here you see it's I and J.
Yeah.
On the, but in fact in the marking scheme they have this one here as the K, which means there's either, you can consider the typing mistake in the exam or the marking scheme, but of course the student can only answer what they're given, so in this situation the marking scheme is not right, and so if you did it using this information you'd still get full marks. Okay, so it means you can't use the marking scheme to check if your answer is right for this. So I won't continue with the last part since it's wrong. Well, I could continue, but it won't match up with the marking scheme. So do you want me to finish doing it?
Just do it.
Just to do it? Okay. So anyways, let's pretend we showed that it was on line L1. And let's go to the next part. He wants the distance between this point on L1 to L2. So show that P is on L1. So what I'll actually do is I'll change the question so that the P is different, so that it is on L1. So let's pretend P is this.
Switch them.
Yeah. 5 minus 8 and minus 1. So if I pretend P is this, then yes, it is on L1. Okay? Right. So, and find the distance of P from the line L2. Now, let me give you some honest advice now. This last part has 4 marks in it, but I feel you do more work than the 4 marks are worth. So the last part here is really just to see if you're going to get the A or if you're going to get the B. Okay? So I'm going to show you how to do the last part. So here's L1. And the P is on it, and the point is 5 minus 8 minus 1. And you know that the lines meet, like here for example, and he wants to know what is the distance between the point and this line. Well, that basically means what's the distance between this point and this point. So actually, in fact, sorry, I was thinking of another question here. It's not as bad as I originally thought because you already have this point. Whereas in previous years, you have to find this point. So then in that case, I feel it's not worth the 4 marks. But anyways, what is this intersection point? Well, we have what the lambda, the mu, the a, and the b is. So if I just sub it in, I can find it. So what is the answer I got for lambda? For where they meet?
Minus 3.
Minus 3. So if I put minus 3 into this, I get 1 minus 4 and 3. Is that right? If I put lambda equals minus 3.
Yeah.
Yeah? So basically I'm just asking for the distance between these 2 points. I'll call it like P and Q. So who remembers how do I find the distance between P and Q? I calculate this vector, the magnitude of PQ. Now, I know I won't pick on you. Joseph, what is PQ, the formula for PQ? Why do you seem unsure? Be more confident, you're right, it's Q minus P. So Q minus P, 1 minus 5, minus 4, minus 4 minus 8 is 4, and then 3 minus 1 is 4. And you want the magnitude of this. So who can tell me what formula goes here? Mustafa, what is it? No, that's the other one. I want the magnitude. Yeah, square root 4 squared minus 4 squared plus that. So what's that? Square root 48, isn't it? Square root 48, which is 4 times 12 for 8 root 3. Can somebody check that on the calculator?
You're right.
No, it's, I don't think it's so. No, that's not right. No, definitely not. It's 4 root 3, not 8 root 3. Okay.
I have a question.
Yes.
Can you go up a bit?
Yes.
Do you see?
So just before you go on, that's the answer. He wants the distance. There's the distance. Okay. What are you saying, Shug?
Yeah, on the thing you drew.
Yeah.
The point on the first line is 5, -8, -1.
This point here?
Yeah, it's for this point.
Yeah.
On the line.
Yeah.
How is that point 1, -4, and 3?
Is here.
That's this point?
Sorry, yeah, it's, I just ran out of space. That's that point, and then that's that point. Q is what I called my answer for where they meet. He doesn't use that letter. He says in part 2, where do they intersect? I'm calling that Q. So what have I not done? Number 3 and number 5. Okay, so in a moment I'll do number 3.
Wait 1 second.
Yeah, let me full screen this.
Yes,
Hmm?
you mean 3B or?
Yeah, I'm going to do all of section B.
The magnitude, you just square the...
Square root x squared y squared z squared.
And we don't give them our answers in decimal? Like we never?
You could, but we'll be fine.
Like they won't subtract marks or
I
anything?
recommend giving both, and then you'll definitely get full marks. Okay, B part now. I mean B3. So in B3, the first question is to integrate this, and you have to use the by parts formula. And firstly, in fact, I have to use this formula. If you remember, the log needs to be before anything else. So firstly, swap. Log x, x cubed, dx.
Is that power x or x ln x?
Log x. Now, in the formula for integration by parts, if you remember, you start off with this is f, which is log x, and this is g derivative, which is x cubed. And then you calculate f derivative, which is 1 over x, and g
Is x to the power 4 or 1.
and the formula is your answer equals f g minus f derivative g, like that, which equals f g, which is that. Well, actually, I'll write it on the next line, but I'm not deleting it. F,
Is that equal?
yeah, f, can't see, g minus f derivative, and then g here. Now that's really nice because what happens here? That cancels that to make 3. So your problem becomes this: a quarter x4, I'll scroll up now, don't worry, log x, Actually, I'll do it now since people are stretching. A quarter x4 log x minus a third antiderivative x cubed dx, which then equals a quarter x4 log x minus a third x4 over 4, and then you put the two limits in, 1 and e. Yeah. Sorry.
About the 4 to 3, 4 or 4. X over
Wait, hang on,
It's
one at a
also
time.
over 3.
Where?
The third line, the first line, yeah. It's over 4. G is x.
Oh, sorry, I wrote it down. It's over 4, thank you. Japers indeed. Right. So there's a 4. Well, I might as well put it in here. 4 times 4? 16. So if I just put them together, 16.
In the last line,
Yeah.
it's x over 16. Didn't you change it to power 3?
I integrated. The integrate symbol here.
Yeah.
Calculator, please.
Here you go.
Apple. Thank you.
You're like an anti-apple person.
Like, I'm very much an anti-Apple person. $10.299. So yeah, we'll definitely round that off to 10.3. I don't know, that was 5 marks. I guess that's not too bad. 5 marks. Good enough. Yes. Scroll up, sorry, yeah. You need to go back to this part, is it? The beginning?
Yeah.
Right, just tell me when to scroll down.
Steven,
Yes.
L for lux, I for what?
Somebody please tell Abdullah what the I stands for. Somebody please.
They are busy.
No, they're not. I don't think they know either. Can somebody tell? No.
Inverse
Inverse of what?
of lin.
No.
Inverse of sine and cosine.
And what's the A?
Apple. What's Kleenex?
Oh! You want to go backwards? Go down. Yeah, okay.
And the A for what?
Alright, I'll say it now.
Why don't you write it down?
Yes, I'm going to say it. Well, it's recording. You can write it. L is for logs. I is for inverse of sine, cos, and tan. A is for algebra, like x squared and x cubed. T is for...
Time.
D is for...
Tan?
trigonometry, sine, cos, and tan. And then the last one you'll definitely get.
Exponential.
E is for...
Exponential.
E. Yes,
Wait, what's the
exponential.
difference between T and I if they're both sine cosine?
No, the I is just the inverse functions of sine and cosine.
But you'd never get like an inverse of sine in an integration.
Oh yeah, you could.
Like integration of sine minus 1.
Yeah.
Then how would you do that? Can you start, can you
Wait, I'm sure there's an example in the past exams. I'll make sure I'll do one like that for you. Actually, yeah. I tell you what. I will. After I finish.
There's no time.
No, actually, I can't finish this. The next part's short. If I don't do it today, I'll do it next time. That one. I think last year there was a tan inverse.
I forgot I saw these things.
Okay, I'm going. Guys, can I go on to the next part? Yeah. So that was 5 marks. So B1, he wants you to write this here. Minus 2x squared plus 17x minus 7 over x minus 3 times x squared plus 4. He wants you to write that as a fraction, partial fraction a over x minus 3 plus bx over x squared plus 4 plus c over x squared plus 4 also.
So you can't open up x squared plus 4.
No, you can't.
So why bx zero?
And that's just how he wants you to write the answer. He gives this to you. Okay. Now, this is 4 marks, but it's actually not too bad of 4 marks, because what you do, I'll do it the quick way, you multiply everything by the denominator here, so you get this result. That will equal a times x squared plus 4 plus bx times
X minus 3.
x minus 3 plus c times
X minus 3.
x minus 3. And sorry, that's not very clear for you. That's a c at the end here, okay? That hasn't really made it clearer. But that's a c at the end anyways. Now, what would be the quickest thing I could do to get one of my a, b's or c's?
3.
Yeah, I could make x is 3, but it may be even quicker, x is 0. Would that? No.
No,
It's 3. It has to be 3. Alright, so 3 squared is 9. 9 times 2 is minus 18.
Does this even?
Oh, yes.
Why do you make
But
x
why did
minus
we get 2x minus 3? There's 2x squared plus 4.
Where? Here?
Yeah, the second one.
Wait. Here?
Yeah, because on the top there is x minus 3, x squared plus 4.
Yeah, what I did was I multiplied everything by x minus 3 first. So if I put an x minus 3 here, it cancels that.
Yeah.
And if I put one here, it cancels that.
Yeah.
But then if I put one here, it stays, because there's nothing to cancel it. And if I put one here, it stays also. But then I also put an x squared plus 4. That will cancel that. And then when I put an x squared plus 4 here, it stays because there's nothing to cancel it.
Yeah.
So that's why there's an x squared plus 4 here. Okay? Right. What was I saying? What am I putting? Minus 3, isn't it? No, x is 3.
How did you get x is 3?
You would just have to look and pick a value that will make things cancel as much as possible. So you see, if I put x as 3, I'll get on the left 26. On the right, these are gone. Yeah, that's gone, that's gone. 3 squared is 9. 9 plus 4 is 13. So what does a equal? 2. Now, what would be a good value to put next? I think I should put x is 0. So I get minus 7 equals a times 4 plus 0 plus c times minus 3. Do you see how I got that?
Is it the second one x minus 0 you make it?
The next one I'm doing x equals 0. So what happens now? I get here 8 minus, is that right?
Why'd you put 4 in the x?
X is 0, so it's just left with 4. If you want to be extra clear, it's 0 plus 4. Would that help you?
No, I mean, what did you use now? Which equation are you? I thought you were doing that one, negative 2x squared.
I'm putting, these always go back into the, the first one up here.
1 over 6.
Is that okay?
5.
Yeah, so this is 8. 8 minus 7 is 1, and then negative 3, so minus 1 over 3 is the c.
No. It's 5.
Upside,
It's 5.
oh yes, of course. I got my signs mixed up.
Same.
So minus 7 minus 8 is minus 15. So minus 15 equals minus 3c, so c equals 5. Now that I have a and c, I can pretty much use whatever value I want to get the b. Because, yeah, I can replace a and c and just say x is 1 or something. So I'll try and squeeze it down here. So making x 1, minus 2 plus 17 minus 7 equals 5a, which is 10, plus 1 minus 3 is minus 2. This is x is 1. 1 minus 3 is minus 2, times 1 is minus 2, and I don't know the b, minus 2b, and then 1 minus 3 is minus 2, times c is minus 10. So 10 minus 10 is gone. 17 minus 7 is 10, minus 2 is 8. 8 divided by minus 2 is minus 4. So b equals minus 4. I'll scroll down for you. So the three values to use, I think, are x is 3, x is 0, x is 1. So now I have the a, b, and c. Yeah? Okay. Just, I won't have time to do the last part, but I have time to give you a small one to do for homework to think about, because it came up last year, and in fact, I don't think anybody got it last year. Everybody got it wrong. So if you want one to think about for homework, and I'll give, the only hint I'll give you, and this hint wasn't given to you in the exam, but I guess if you were being smart about it, you would have thought about using this hint because of it being in question number 3, I think. Nope, definitely not that.
No, 1 over.
No, definitely not this. My advice is try to use integration by parts to solve this. By parts.
So 1 over cosecant.
No, not this.
Cotangent.
Cosine.
No. Have to think about it for homework. But I'm telling you, it is integration by parts. And the other one, which they also asked last year, or maybe the year before, or maybe a different version of last year. Again, what's this?
1 over x.
No,
Why? It is 1 over x.
no.
Really?
The derivative is 1 over
Oh,
x.
yeah.
But you have to use integration by parts also to solve this one.
What's the different part of it? You only have one part.
Exactly, so you have to have a think about how you're going to make another part.
Like a
So-
C or something?
Not this, no.
No, the first one is gonna be done something in the answer.
Can we use
Done
part?
something.
No.
Yeah.
Make it to
Do you need another hint?
Yes.
To use integration by parts, how many functions do you need? 2. How many are here?
1.
1.
Oh.
Well, yeah, in each case there's 1. And now, if I put a multiply 1,
Okay.
nobody figured this trick out, even though I showed students in class this trick. Because for some reason, students forget things. For some unknown reason.
Why don't you remember?
So, I can't remind you in the exam, but I'm telling you now, if you see something that needs integration by parts and it only has one function, the second function is actually the number 1.
Sure.
But if you think of it, it is because everything was multiplied by 1.
Exactly.
Not 6.
But the important thing is, will you think of it in the exam? Yes, now you will.
Okay.